7-36, and this is not so different from what we've been doing, and so we'll kind of walk through it a little bit. 35 says a study conducted by a nationally known horse health club revealed that 30% of its new members are 15 pounds overweight. A membership drive in the metropolitan area resulted in 500 new members. It has been suggested that the normal approximation, it says, does this problem qualify as a binomial problem? Explain. I don't think you guys have to answer that, but the explanation would be on page 227, right under the continuity correction factor, the second paragraph there. It gives the 4 things that you look at for a binomial probability. So the answer is that it is, and those are the 4. It meets the 4 criteria. But B, it says, what is the probability that 175 or more of the new members are 15 pounds overweight? Well, again, we just input the data, right? I got to start up here. I'm sorry. My answer for A was yes, but so I've got N is 500. That's my sample size. My probability is 30%. My mu, or my average, is 150. Okay, remember my probability times my N. Okay, so that's the average number. What that means is that's the average number out of 500 that we would expect would be over 15 pounds or more overweight. Okay, my variance then, remember, is just my mean times 1 minus my probability. Okay, so it's 105, and then my standard deviation is 10, a little over 10. Okay, taking the square root of 105, I end up with 10. So now it's kind of important to note. It says what's the probability that 175 or more of the new members? Well, remember, a standard deviation is 10. Okay, and I'm at 150 for a mean, so to get to 175 is going to be 1, 2, almost 2.5 full standard deviations. Okay, so that's a high threshold. Okay, that's a very high threshold in that case. And what's the probability that more than that would be above that above that threshold of being 15 pounds or more overweight? Okay, that's a big threshold, so I'm going to expect that the number's going to be small, right? Because we have to, if we look at my handy dandy new play toy, okay, I'm 2.5 or thereabouts, right, deviations, okay, and so I can just kind of look at this, but it's going to be everything, because it's everything here to the left plus 2.5, so I got to be looking for something in that 99% range probably, right? Okay, so let's go take a look and do the math then. Okay, and remember, we got to apply the continuity correction. Okay, and so in this case it's 175 or more, right? 175 or more, and so again, if we look at that, at least x occur, use the area above, so I got to go x minus, so I do that. Okay, I plug it in again. We've done this, so I won't walk through it, but my Z then becomes the 2.39, I was saying about 2.5, but 2.39, so if I come here and inch it on up, 99.16, okay, but I want just to the right of that, okay, I want just to the right of that, or I can hit the Z onwards, right, 2.39, okay, so 0.84%, 0.0084 is roughly what I'm looking for, okay, and I can get it the other way too, right? I can look up my deal for the Z, and the 239 down here, 2.3, and 9 is going to be over here, so 0.4916, right? Either way, I come up with that, but I have to do, in this case, when I come up with this answer, I have to do the inverse. I could subtract this one from 0.5. Okay, if I do this one, which I did the normal distribution, then I have to do the complement rule, and it comes out to 0.0084. So Okay. And then the similar question, but it has to do with what's the probability that 140 or more new members are 15 pounds overweight. Well, now I'm about one standard deviation to the left, right? Okay, so I'm going to have all of, I'm going to have everything to the right, okay, oops, where am I? Plus about one standard deviation there, okay, so I should be around that 84%, somewhere in that neighborhood. And again, I can do the math. I have to do let's see here, it's what's probably 140 or more, so again it's going to be, this is equal to this minus 0.5 to get the factor in there. I've done the math, z-value, that's what I come up with. I'm sorry, this is my z-value. This is the number then that I get when I look it up in the chart based on that z-value. I add, in this case, the 0.5, right, because I knew it was going to be a pretty good sized number, and I said I thought it would be around that 84-85%, okay. And I can also do the normal distribution, come up with it that way, and I come up with pretty much the same answer.